Hello guys and welcome back to my channel. This is going to be the last video tutorial for this unit 1 of the IGCSE Computer Science textbook. In this video tutorial guys, I'll be wrapping up this topic, which means I'll be focusing on the use of the hexadecimal system. We actually have 5 uses in this section review. So we're going to be looking at these 5 uses of hexadecimal systems as opposed to binary systems and try to understand how they're used. And then we'll finish wrapping up this unit, and in the next video tutorials I'll be creating videos that will start to explain the IB curriculum on Java programming, and of course I'll continue to create more videos, content on this IGCSE Computer Science next unit of Unit 2 as well. So without further ado, we're going to be looking at the first use of hexadecimal systems, and we pretty much use them in memory dumps. So just to give you a clear definition of what a memory dump is, it's basically the memory contents that you get to have outputted in your printer or on your monitor. So it contains the information, I would say the back end, not the front end, because if you look at your monitor, you pretty much just see the information that you want to get displayed to you. But if you look at the back end, it's made up of memory dumps containing different memory locations of different aspects of a program code for the information displayed on your computer system. So the first use of the hexadecimal system is the use of memory dumps. They are made up of, so these numbers that you can see here, it says it's much easier to work with this number as compared to a binary number. Obviously, we've seen that hexadecimals are represented with 4-digit codes, and binary is usually long. We have an 8-bit, which makes up a 1 byte, so it's easier to represent memory locations in our computer system, which we call memory dumps, using hexadecimal digits than using binary. So that makes it easier for programmers or people who create new softwares to be able to trace any errors in the program. So if you look at this figure 1.6, you see on the far left they contain memory locations, which contain each separate line of codes, or in this case you can see numbers and hexadecimal digits. So if there was a problem with a certain program or a certain code of the computer system or device, the programmer can easily trace them because it's more manageable since we're using hexadecimal values. They're shorter to use and trace instead of binary, which could be really cumbersome in this case. So the programmer can look at the hexadecimal codes as you've seen above, which is again on the left side, all these codes are basically called a memory location. For every information or data that we open or output on our computer system, that gets to be stored on a memory location. So the programmer can easily trace where the problem is. If an error has gone wrong, as I mentioned, with the code or with the program, he or she can easily trace it just looking at the memory location, which is represented by hexadecimal digits and values, as well as the code itself or the information, which is on the right, represented again by hexadecimal digits and values. So the far value on the far left is basically containing the memory location, and it is possible to find out exactly where in the memory the fault lies. It is also clearly more manageable using hexadecimal than binary, and is one of the most powerful, very powerful fault tracing tool, but it does require a knowledge of computer architecture. So only if a person is tech savvy or a computer programmer or engineer, you can actually interpret this by looking at where the error is, and you can determine how to fix that error. The second use of the hexadecimal system is applied in the hypertext markup language, which is HTML. I'm sure some of you are familiar with HTML. HTML actually is used to be able to to be able to create websites. A very common hypertext markup language. It's actually not a programming language, but it is used to confine the way text is presented, processed, and displayed. So it deals more with the aesthetics of how information is displayed for users, especially when creating websites. So how has the use of hexadecimal applied to this part of this area? Well, we know that HTML uses tags, and basically codes are represented in tags, whether you want to create a table, or you want to create a row, or you want to create a navigation bar, or you want to create an image gallery, depending on what you're trying to create in your website. But it also contains color coding that you use to insert colors into your website to make it look nicer. So these color codes are basically represented using hexadecimal values or digits, and they represent colors that get to be displayed on your website, which gets to be displayed on your screen. So as you can see here on this example, we see that #FF00 represents the primary color of red. We have 3 primary colors in HTML, which are then mixed together to form other colors, just like I think what you do in art similarly. So the second color, hashtag 00FF0, represents green primary color, and then the last one represents blue. And then you see that we have more different color codings that are used to create other colors. And these color codes, as you've noticed, they're represented using hexadecimal, which again makes it more easier and more manageable to represent hexadecimal values. Because remember, we had 3 primary colors, which eventually have to be mixed, just like you do in art, to create other colors. So it's more manageable to use hexadecimal values to represent those primary colors. So when they're mixed, it's easier to replicate other colors than to use binary, which would be more cumbersome. So again, hexadecimal does play a very major role in the world of HTML. The other use of hexadecimals, you notice, guys, that I'm skipping the activities. These are some things that you can try to do on your own, just as a practice review to see if you understood what has been explained. But the next type of example used for a hexadecimal system is with the MAC address. So MAC address basically is just explaining the unique address of each digital device. Not on the network. It doesn't necessarily have to be on the World Wide Web network. It's just an identification of each digital device in your home, in your office, in the school. It must contain a MAC address which uniquely identifies that device. And it refers to the network interface card, which is the NIC, and it's part of the device. So the MAC address will normally be the NIC, and if you look at your computer, you see it by the right or left, you must have a port, which is usually named as the NIC, which is where the network interface card goes in, which contains your MAC address. So how has hexadecimals applied to the MAC address? Well, the MAC address is typically made up of 48 bits, which are divided into 6 groups of hexadecimal digits. The first half of these identity number contains, I'm going to repeat that. The first half of the MAC address basically contains the identification number of the manufacturer of that device. So again, hexadecimal plays a role here because the MAC address is made up of hexadecimal values, but it's divided into segments of 2. So first part represents the identity number of the manufacturer of that device. The second half represents the unique serial number for that particular device. So there is no replication of 2 different types of MAC addresses. So here's an example of how a MAC address is, and they further explain and say MAC address of a device produced by Apple would normally start with this code and then with a serial number of that. So sometimes they said lowercase hexadecimal letters are also used to represent or used in MAC addresses, and they further give you examples of different first half of MAC address for different manufacturers like Dell. It always starts with this group of 6 digits. So the first half of the device itself, if it was made by Dell, and this one is if it's made by Cisco, and this one if it was a processor made by Intel. So this just further explains to you how the whole situation of MAC addresses work. Again, they make use of hexadecimal values to represent these MAC addresses, which is more manageable. Now we're going to be looking at the different types of MAC addresses. We have the universally administered MAC address, which comes from the manufacturer directly. So when you purchase any device, it usually comes with its own MAC address from the company, unless if you change it, and then that becomes the locally administered MAC address when it's changed. It is a rare situation, but sometimes it does happen depending on what needs to be done, or depending on maybe some MAC addresses in a particular company or organization need to be in a particular format. So, however, there are some organizations, like I mentioned, where a user would need to change their MAC address. In that case, the MAC address would no longer become universally administered, but it will just become locally administered. We're going to be looking at some situations where the MAC address would need to be changed from UAA to LAA. So some situations include certain software or the mainframe system need all MAC addresses to fall into a strict format because it may be necessary to change the MAC addresses of some devices to ensure they follow a format. So a situation where the MAC address will be needed to change from a universally administered MAC address to a locally administered MAC address would be where they would need to fall in one strict format. Another situation would be where the MAC address would be used to bypass any MAC address on a router, MAC address filter on a router or a firewall. So they would have to be set in a certain format so they could bypass that filter, and in that situation they have to be changed. Another situation is if they want to be able to get past certain network restrictions, then of course it will be necessary to again change the MAC address so that they could be able to get access to that network, because that network, only grants access to specific type of MAC address formats. So these are basically some 3 examples of situations where MAC addresses would need to be changed from being universally administered by the manufacturer of the device into a local administered MAC address. The last use of the hexadecimal system, well, the second to the last use is to using them in web addresses. I think I mentioned this in my previous video tutorials, and I said in our computer systems, we all have keyboards, and our keyboards, whether they're built-in or external keyboards, they contain keys and characters. Now, these keys and characters are represented by specific hexadecimal values in something we call the ASCII code table. It's the full name is the American Standard Code for Information Interchange. And why are these keys on our keyboard represented in hexadecimals? Because remember, the computer is digital and does not understand anything other than binary of ones and zeros. If we were to represent each of the keys on our keyboard in binary, again, you can imagine how long that would be as opposed to hexadecimal. So that's why they decided to represent this organization, or should I say this body, ASCII, decided to represent every single key or character on our keyboard using hexadecimal values or decimal values instead of binary. So here's the typical ASCII keyboard, and you can see toward the left there's something called DEC, and that represents the decimal values, and then you see the hexadecimal values of those particular characters that we find on our keyboard, from space up to the last character you have. So all the characters are represented here on the ASCII code table. So you see again that we use hexadecimal to represent characters because it's more manageable and it's easier to store, to convert from hexadecimal into binary, so that the computer can understand what key you've pressed as represented directly on a low-level programming language. So here they give us a very good example of how ASCII codes are used to represent different web addresses. Like whenever you have any single web address, they always start with the HTTPS, which is the Hypertext Protocol, Transfer Protocol, and it's S for secure. Now then after that, you're going to see the URL address. Now those addresses, because they're using characters and letters, they are also interpreted using hexadecimal values on the network. So they give you an example of here, www.hoder.co.uk, and they basically find the equivalent hexadecimal values on the ASCII table to represent this website. So W is represented with the 77 for the hex value, and the same thing goes for the other WW. So we put a percentage sign because it's used to denote that this is a hexadecimal representation. So, and then the dot, of course, even the dot has its own representation in hex, and it's 2E, as you can see here on the top of the table. And again, the H, if you look at the H and you see the equivalent representation, you see it's a 68. So this is how web addresses are interpreted into hexadecimal values when being used. So we're going to do one example here. We're going to take the first example A, just to see how we can interpret in case you have an exam question or test question. Usually they do come out, guys. So I'm going to do activity 1.9, and we're going to be looking at the first example. We're trying to interpret this URL address or web address into hexadecimal representation. So we have www, okay, and we have .cie.org.uk. So .cie, and then we have .org, and then we have .uk. So this is the website we have. Now we're going to interpret this looking at the ASCII table. We're going to look for the equivalent hexadecimal representation of each letter or character here. So www, we already know that W is represented as 77. So we're going to put the percentage sign to signify that this is a hexadecimal representation. So percentage 77, right, for the first W. The same thing goes for the second one, percentage 77. And then we get the third one, which is going to be percentage 77. So this is the interpretation to hexadecimal. And then we get the dot, so we're going to have to go find what dot is represented by. So it's represented by 2E, so we're going to do the same thing again. We're going to write percentage 2E. I'm going to put it down, guys, for spacing. And then we're going to look at C, what is its representation. Make sure you check very well to see if it's a small c or a capital C because they're different. So it's a small c and the representation is 63. So that means we're going to write it as percentage 63. Okay, so I'm going to put it down again, 63. And then I, we're going to look for the I, and it's 69. So we're going to write it as a percentage 69. So this is going to be percentage 69 for I. And then the next one is E. So we're going to look at what E is. Again, it's a small e, so we need to find the equivalence. It's 65, so that's going to be percentage 65 again. So percentage 65. So I hope you guys are getting the idea of how this works. We have dot again, so we don't need to look. We already know it's going to be a percentage 2e. So percentage 2e, because we already have done it previously. Now we're going to look for O, which is a small letter O. Again, the lowercase or uppercase does matter, so it's a lowercase o. So we're going to look for its equivalent, which is going to be 6f. So we're going to write it as percentage 6f. And then we're going to look for R. So we're going to go back to the table again. We'll look for small r, which is represented as 72. So we're going to write 72. Again, guys, we're using the percentage sign just to signify that we're representing this in hexadecimal. So 72. And then we have G. So we're going to look for what G is, lowercase g, and that's percentage 67. So we're going to write that down. I think I'm going to take this up here, guys, just for spacing. So G is percentage 67. And then we have the dot again. So we already know that a dot is a percentage 2e. We've already done that. So it's 2e. And then we have U. So we're going to look for lowercase u. What its equivalent is 75. So it's going to be percentage 75. So I'm going to take it up again, guys, just for the spacing. So percentage 75. And then finally, we're going to look for the K. So K is represented as a lowercase, which is 6b. So that's going to be percentage 6b. And this is pretty much how you interpret, you know, a URL using hexadecimal notation. So that's one of the uses of why we use hexadecimals in terms of web addresses. And finally, why do we use hexadecimals for assembly code, machine code? We know that assembly code and machine code are considered as low-level programming languages. So it is much easier for a programmer to write code or to check errors in codes using hexadecimal than using binary, because you can imagine, again, it's going to contain a long time. It's going to take a long time to be able to key in your values for your code, as they've mentioned here, and it's going to be too cumbersome. So again, this is why the use of hexadecimals fall for when a computer programmer is trying to program or create a high-level programming language. In that sense, it will, you know, it's much easier to use hexadecimals than to use binary. However, machine codes and assembly codes are usually used when creating computer games by program developers. In that case, it just directly goes into, there is no need for interpretation, guys. That's what I mean. Because when you create a code in high-level programming language, it needs to be interpreted into machine language using either a compiler or interpreter. But if it's written directly in machine code, even though it's really quite cumbersome and you have to have knowledge of computer science itself, then you don't need to have you don't need to interpret it into anything of a machine code, because it's already at a basic level. So the use for hexadecimals for assembly code, machine code is that it's easier and it's less prone to write errors when, less prone to errors when you're writing code as compared to binary. So guys, this is where we've come to the end of Unit 1 for the IGCSE Computer Science textbook. The next time we'll be covering the IGCSE Computer Science, we'll go to Unit 2, which talks about communication and internet technologies. And after this, I'll be creating video tutorials that will be addressing IB computer science, just to kind of interchange it from what we've done. I would suggest you guys to revise through the video tutorials and revise through these activities just to check and see if you've understood everything. And then we'll continue in our next video tutorials from where we stop. And I'll be coming with a new series of the IB computer science curriculum on Java. So I hope to see you guys next time, and I hope this video really helps you guys to understand these units so far based on what I've explained, and I wish you guys a great day and see you next time.